Hi guys, welcome to Easy Math.
In this video, we are going to discuss about the next topic in Unit 2, that is homomorphism. For that, first we have to discuss about the definition for the homomorphism. A mapping pi from a group G into a group G bar is said to be a homomorphism if for all a comma b belongs to G, phi of a into b is equal to phi of a into phi of b. A mapping phi from G to G bar is to be a homomorphism if for a comma b belongs to G, phi of ab is equal to phi of a into phi of b. Okay, that means you have to consider a mapping from G to G bar. The mapping pi is said to be a homomorphism. You have to choose any two elements from the group G, then the term pi of a into b can be written as pi of a into pi of b. Pi of a and pi of b and pi of ab are the elements from the group G bar. Okay. Next definition is the bijection. A mapping phi from G to G bar is said to be a bijective if it is both 1 to 1 and onto. If it is both 1 to 1 and onto. A map phi from G to G bar is said to be bijective if it is 1 to 1 and onto. What is meant by 1 to 1? 1 to 1 means if the element pi of a is equal to pi of b, then a is equal to b for all a comma b belongs to G. This 1 to 1 function is also known as injective function. Onto means every element of this G bar has a pre-image in G. Every element of G bar has a pre-image in G. This onto function is also known as surjective function. Okay. Next we are going to discuss about the next definition, isomorphism. Let G and G bar be two groups. A map phi from G to G bar is called an isomorphism if first condition is phi is a bijection. What is meant by bijection? Bijection means it satisfies the 1, 1 and onto condition. And second one, phi of AB is equal to phi of A into phi of B for all A comma B belongs to G. What is this condition represents? It represents the homomorphism condition. Okay. Therefore, a mapping phi from G to G bar is said to be an isomorphism if it satisfies two conditions. First one is bijection and second one is the homomorphism condition. Okay. This is the homomorphism condition. Okay. Two groups G and G bar are said to be isomorphic if there exists an isomorphism from phi from G to G bar. If there exists an isomorphism between these two groups means we said that the two groups are isomorphic. We said that two groups are isomorphic. We simply write that isomorphic groups as G is isomorphic to G bar. This is the symbol which we are going to represent for isomorphic. Okay. Two groups G and G bar isomorphic means we read it as G is isomorphic to G bar. Okay. Now we are going to discuss about the next definitions. Let phi from G to G bar be a homomorphism. If phi is 1 to 1, then it is called a monomorphism. If phi is 1 to 1, then it is called a monomorphism. If phi is onto, then it is called an epimorphism. Okay. What is meant by 1, 1? Phi of A is equal to pi of B implies A is equal to B for all A comma B belongs to G. Then phi is said to be 1, 1, right? If phi is onto means every element of G bar has a pre-image, right? Every element of G bar has exactly one pre-image in G. Phi from G to G bar be a homomorphism. Homomorphism means it satisfies the condition phi of AB is equal to pi of A into pi of B. If it satisfies that condition, together with the pi is 1, 1 means it is said to be monomorphism. Together with pi is onto means it is an epimorphism, right? Next definition is a homomorphism of a group to itself is called an endomorphism. What is endomorphism? A homomorphism phi from G to G. Homomorphism of a group G to itself. That means G to G means it is called an endo. If phi from G to G is said to be a homomorphism, means this homomorphism is known as endomorphism. Is it clear? Next definition, if phi from G to G bar is an epimorphism, then G bar is called the homomorphic image. This is the homomorphic image of G. Okay, this is the homomorphic image of G. Phi is an epimorphism. What is an epimorphism condition? Phi is a homomorphism together with onto. Then phi is an epimorphism, right? Then G bar is called the homomorphic image of G. Homomorphic image of G. Next definition, automorphism. An isomorphism of a group G to itself is called an automorphism. An isomorphism of a group G to itself is called an automorphism. What is isomorphism? An isomorphism of group G to itself. That is, isomorphism means phi is bijection and the phi satisfies the homomorphism condition, right? That means it satisfies 1, 1, onto, and the homomorphism condition means that function is said to be an isomorphism. An isomorphism mapped from G to G itself means that mapping is called as an automorphism. Okay. Next definition, the set of all automorphisms. The set of all automorphisms of G is denoted by A of G or automorphism of G. Set of all automorphisms. Set of all automorphism means we call this phi function, f function, g function, like that. The set of all automorphisms of G is denoted by A of G. Next definition is, let phi from G to G bar be a homomorphism, then the kernel of phi. Then the kernel of phi is defined by k phi is equal to, that is kernel of phi is equal to set of all x in G such that phi of x is equal to E bar. Phi of x is equal to E bar, where E bar is the identity element of G bar. Where E bar is the identity element of the group G bar. Okay. Kernel of pi is denoted as capital K or kernel pi or K pi. In some textbooks, that homomorphism function phi is defined as f. Here phi is defined from G to G bar, right? In some textbooks, they mentioned as f from G to G dash, but both are same only.
Thank you for watching. Don't forget to like, share and subscribe. Bye guys.